Look at the part 1. f of x equals b to the x power b greater than 1 and b is not equal to 1. The graph will be like this. You could say this is an increasing function. We will create the table x, y, 0, -1, 1, 1 over b, 1, and b. For the domain, x is all real numbers. The range y greater than 0, there is a horizontal asymptote line here. Y equals 0 is a horizontal asymptote line. When we have f of x equals 1 over b to the x power or 1 over b to the x power or b to the negative x power for b greater than 1 and b is not equal to 1, you could say this is a decreasing function. We call this is a exponential growth, and a decreasing function like this is an exponential decay. For the table, still x, y, -1, 0, 1. This is a b, 1, 1 over b. Domain is the same. Range is the same. Horizontal asymptote line is the same. Y equals 0. Let's draw a conclusion. For f of x equals a times b to the x power plus c, when b greater than 0 and b is not equal to 1, the horizontal asymptote line will be y equals c. For f of x equals b to the x power when b greater than 1, it's an increasing function. When b greater than 0, less than 1, it's a decreasing function. Let's go to part 4. Sketch the graph according to the transformation. For number 1, f of x equals -2 times 3 to the x minus the 4th power plus 1. This is an exponential function. We know the horizontal asymptote line. It's a y equals 1. For the transformation, we have 1, 2, 3, 4. For the translation, we will use a vector. For first step, reflect across the x-axis. For second step, a vertical stretch with a scale factor of 2. For third step, a translation through +4, 1, which means move to the right 4 units and go up 1 unit. For the parent function, y equals 3 to the x power, x, y, -1, 0, 1, 1 over 3, 1, 3. We have these 3 points. Let's draw the horizontal asymptote line first. Y equals 1. For this point, reflect across x-axis, go here. Then the distance from x-axis multiplied by 2. 1/3 times 2 is 2/3. We'll go here. Then move to the right 4 units. 1, 2, 3, 4. Go up 1. It's here. Let's go to this point. Reflect across x-axis. Then the distance from x-axis times 2. Go here. Move to the right 4. 1, 2, 3, 4. Go up 1. It's here. From this point, reflect across the x-axis here. A vertical stretch with a scale factor of 2. Multiply by 2, go to -6. right 4, 1, 2, 3, 4, go up 1, it's here. Then connect these 3 points now. This will be the graph. Let's go to second question. F of x equals 3 to the 2 times x minus the fourth power minus 1. Y equals -1 is a horizontal asymptote line. Transformation 1 and 2. 1 is a horizontal stretch with a scale factor of 1/2, which means the distance from y-axis will be half. For second step, a translation through 4, -1. Move to the right 4, go down 1. We know y equals 3 to the x power is the Pernow function. So we will get these 3 points. Let's draw y equals -1 as a horizontal asymptote line. Horizontal stretch with a scale factor of 2. The distance from y-axis will be half. Go here. Then go to the right 4 units. 1, 2, 3, 4. Go down 1. So this is the point. For this point, horizontal stretch with a scale factor of 1/2, the distance from y-axis is 0. So this is a state. Then move to the right 4, down 1. 1, 2, 3, 4. Down 1 is here. Then for this point, the distance from y-axis will be half. It's go here. Then move to the right 4. 1, 2, 3, 4. Go down 1. It's here. Then we connect these 3 points. This will be the graph for number 2. Let's go to number 3. F of x equals -1/2, 1/3, x power plus 1. We will change this into the function with the base 3. We do know that 1/3 of x power equals 3 to the negative x power. So we have -1/2 times 3 to the negative x power plus 1. The horizontal asymptote line y equals 1. 1, 2, 3, 4 steps. The first step, reflect across x-axis. Second step, vertical stretch with a scale factor of 1/2. The third step, reflect across the y-axis. The fourth step, a translation through 0, 1. That means go up 1 unit. We know the Pernow function y equals 3 to the x power. First step, reflect across the x-axis here. Then vertical stretch with the scale factor 1/2 means the distance from x-axis will be half. It's just more closer to this x-axis. Then reflect across the y-axis, go here. Then go up 1 unit will be here. For this point, reflect across x-axis here. Vertical stretch with the scale factor 1/2 will be half of this. Then reflect across the y-axis state. Go up 1 is here. Let's go to this one. Reflect across x-axis, go here. Vertical stretch with the scale factor 1/2 is go here, this one. Then reflect across the y-axis, go this. Go up 1, it's here. This point, y equals 1 is a horizontal asymptote line. Then we will connect these 3 points. This will be the graph. For number 4, f of x equals 1/3 to the 1/2 x plus 1th power. We will change into the exponential function with the base 3. So 3 to the negative 1/2 x plus 1. That equals 3. Take a 1/2 outside. We will get x plus 2. The horizontal asymptote line, y equals 0. Translation steps. This is the first step, second step, third step. Reflect across the y-axis. Second step, horizontal stretch with a scale factor of 2, which means the distance from y-axis will be doubled. Then third step, a translation through -2, 0, left 2 units. The parent function still y equals 3 to the x power. X-axis is a horizontal asymptote line. So for this point, reflect across y-axis here. Horizontal stretch with the scale factor 2, that's go here. Then go to the left 2 units, go here. Let's check this point. Reflect across y-axis stay. Horizontal stretch with scale factor of 2 stay. Translation through -2, 0. Move to the left 2 units is here. Then go to this one. Reflect across the y-axis here. Horizontal stretch with the scale factor 2. Double the distance from y-axis, go here. Then move to the left 2 units, 1, 2, it's here. Then we need to connect these 3 points. This is the graph for number 4.